purchase shares, average equipment lifespans, things like code changes we can input and modify in there, such as a new efficiency standard for furnaces, like Monica mentioned, could be a case for us. The third step is the baseline module. Once again, we highlighted that pretty recently here. It's the amount of gas used without the implementation of energy efficiency for comparison. And then based upon that baseline, we're then able to add some non-equipment measures and some other items, then get to the potential. The non-equipment measures, think about envelope typically. Insulation, thermostats, windows. We're able to input assumptions for single families, multifamilies, what type of U factors are included for windows, for example, different insulation standards. We're able to input all that in there, and it gets some different adjustments to our forecast for the potential. And finally, of course, is that potential. It's a combination of the 4 items. We link them into that final spreadsheet, make some adjustments to where we think the assumptions lie, and then it actually creates forecasts for us. It's got potential by end use and much more. So it's able to actually segment out depending on what information we're actually looking for. Monica, I think, will actually mention this as well in the future. But that actual load map analysis we're using was structured and developed for our 2021 CPA, which had a forecast window of about 20 years out to 2040. However, with our IRP cycle at the 2050 at this point, we were able to modify the load map to run through 2045 quite well. However, 2046 to 2050, we're not able to be incrementally added into the framework. Instead, there are estimates and averages from 2040 to 2045, which were then used to backfill those final 5 years. I think Monica will talk about that just a touch, but that's just something I want you to keep in mind where, of course, nothing's perfect, but in this case, the time horizon would be something to think about. We'll go to the next slide here if no questions pop up. All right, Monica. Yeah.
As Caleb mentioned, the 2046 through 2050 is estimated based on it utilizes the annual savings average for 2040 through 2045, and really that's because that's how the model was built from that original CPA. Our IRP this time is going out to 2050, as Brian and Devin have mentioned throughout the different tag meetings, because we're really trying to look at what our obligations are through the 2050 horizon. So we tried to accommodate. We are working within the structure of the existing conservation potential assessment. So we'll make sure with our future CPA, we'll be doing one every 2 years, and we'll make sure that it does accommodate the longer horizon. Assuming that the model can do so. So just something that's changed from our last IRP to this one, it's a longer horizon. So in speaking with the commission staff, Cascade did rerun our load map model from that most recent CPA, which was filed in 2021. I can give you the docket number if you'd like it, just for reference. But for this rerun, we actually updated the avoided costs with this new IRP. As I mentioned, the time horizon is a little different. 2050 is used for the 3 scenarios that we actually did run. You'll see there's 4 sets of bars here. The first being the original 2021 CPA, and then we've got the 3 additional scenarios. Scenario A takes the original 2021 CPA models and updates the input assumptions to match those in Cascade's 2023 IRP. Including updates to the market growth, the avoided costs, and weather assumptions, which now assume declining heating degree days over time as opposed to flat normal weather throughout the forecast. Opposing trends create a net decline in potential compared to the original CPA models. However, on one hand, an increased customer forecast-based market growth trends increases opportunities for strongly cost-effective measures like residential furnaces, water heaters, and fireplaces. However, the lower avoided costs and declining weather-sensitive use over time have cut the cost-effective potential in some measures as marginal segments struggle with that cost-effectiveness. With the higher avoided costs in the RNG future scenario, which is scenario B, that's the third set, what is that? The light blue parallel lines. The residential furnaces and water heaters gain significant ground as more segments clear cost effectiveness testing, but there is little impact on other measures compared to scenario A. This results in total potential similar to the original 2021 CPA. And then scenario C also uses the RNG future avoided costs, but modifies the customer projections to include existing and expected local bans on new natural gas connections. This decreases the available opportunities and resulting potential significantly, resulting in overall potential similar to what we saw in scenario A, which is that updated base case, let's say, updated from that 2021 CPA. Keep in mind, we don't know exactly what will happen with gas bans. We know of one territory with a gas ban now, and we will continue to gather information to gain a clearer indication in the future. So when we're talking about that scenario run here, Brian actually mentioned it. It's from the Bellingham ban on commercial natural gas usage moving forward for new homes, or excuse me, not new homes, new construction. So that's one that we actually have incorporated here. We know that there will likely be more bans, or at least considerations in the future. So this was our first attempt at incorporating it into the conservation potential assessments, as AEG or our models have not done that before. So next slide, please.
Monica, real quick, we have a couple of questions in the chat.
Oh, interesting. Okay.
So from Heidi, can you clarify the correlation between the energy usage variation versus the demand usage variation with different types of demand response programs for the different customer sectors?
Sorry, I'm just reading it, so I understand. You know, I might ask, Caleb, do you think that you might be able to answer this a little better than I can? It's okay if you can't, because I can circle back around.
Yeah, I don't think I have much more insight than you do in this. One thing we could always do is partner up with AEG and as far as how this is implemented into the model and where the forecasting of it is.
And just to be, this is Heidi Caswell from the OPUC, and just to be clear, what I was just trying to understand was the extent to which you have granularity by the program types in order to understand their effect on demand, as well as the energy reduction, in terms for a given period, a year or whatever it might be.
Are you asking about the forecast that we actually plugged into the model to be able to come to the numbers, like what the input is that we provide to AEG?
Well, and the extent to which you would then be able to tie it to a specific program. And where I'm really trying to go with it is the next conversation is going to talk about distribution improvements. And so it's the question of whether there are, you said you had the 0.9 tests that you use to allow some kind of grace, I guess, in selection of different initiatives to pursue. And maybe if you have a extremely expensive distribution investment, maybe 0.85 is a better number because it would let something else in the door that might help, a distribution capacity improvement. So I was just trying to understand the correlation, the granularity, and the specific ties between those different activities that you're doing.
Yeah, that's a really good question, Heidi. I'm sorry I didn't quite get it when you were first asking. The model allows us, I mean, we can go lower than 0.9, right? I mean, it shows us what that actual level is. So if we wanted to look at a specific measure, we certainly could look at one that's a little bit lower than that. To your point, I think that in the new realm of what we need to be considering, and specifically for Washington, we're supposed to be looking at all cost-effective measures. I mean, we're supposed to be adaptively managing. We're supposed to be really looking at some new opportunities for increasing uptake on these energy efficiency measures. So maybe to your point, lowering it would make sense. It's really that portfolio level that we're looking at. So as long as we're cost effective at that level, and really we want to be cost effective at the program level as well, not just portfolio, but being able to accommodate a little bit of give and take there too. That and maybe that does mean looking at it down the road when you're talking about the demand response programs themselves. So it'd be worth exploring a little bit deeper, certainly.
Great, I appreciate that.
Thank you. And I think the other question was declining heating degree days.
Yeah, and I could take that if you want me to. So
Sure.
In tag 2 for our forecast, we had mentioned that we are using normals that have climate change impacts as part of it, and we discussed the what model we used. So I'm trying to remember off the top of my head what it was. But I can circle back with you on what exactly it was that we did, but we incorporated climate change in our future normals, and that's why the HEVs declined over time.
Yeah, and we're
Okay,
going to
I
cover that a
just-
little bit in distribution modeling too. So
Awesome. I'd love to see how those connect together.
And then Carolyn asks, when you say gas bands, what exactly does that entail?
So I think, Brian, do you want to speak to it then?
Yeah, so essentially it's just anywhere where there may be a ban on new appliances or new construction that forces a business or customer to go to electric rather than to gas. So for example, in the Bellingham one, and the earlier slide, we had showed that it was for new commercial and then large residential buildings. So it kind of depends on the location and what the gas ban itself entails. So yeah, it's basically just a ban on natural gas.
Okay,
And I
thanks.
think it'll come in different formats depending on the territory you're in. The Bellingham one, I believe, was modeled after Seattle's commercial property ban that I want to say last year was put into effect. Okay. So this slide is a line graph version showing the same data as the previous bar graph, but expanded through the time horizon of 2045 for the 3 scenarios. You'll note the RNG future scenario with the highest avoided costs peaking in the chart, while our scenario A, which is that 2023 IRP reference case, and scenario C, the RNG future and gas ban scenarios, are nearly identical throughout the time horizon. Upcoming charts will focus on that scenario A, which is the IRP reference case, the updated inputs just for this IRP from that last conservation potential assessment. Saving numbers for scenario C, which is the RNG future and that gas bans scenario, are very similar to the scenario A, which is the 2023 IRP reference case. Savings numbers for scenario B, which is the RNG future only, are approximately 25% higher on average through the time horizon. And you'll note that the dashed line stops at 2040. And again, that's because that's what the CPA was actually created. That's the time horizon, and the others is, they extrapolated out, as I mentioned. Okay, next slide, please. Yeah, that's all right. Okay. So for the energy efficiency cumulative potential forecast, the combined portfolio of residential and commercial industrial shows steady growth over the forecast horizon, culminating with approximately 48 million technical potential therms by 2045. The utility cost test economic potential standard for our programs, again, is forecasted at 13.1 million therms of savings through 2045. So, and again, that's cumulative as opposed to incremental. Next slide. I'll let Caleb go from here.
Yeah, I appreciate it. We've got right around 10 or so slides we're going to go through relatively quickly here. They showcase fairly similar information, just broken across our commercial, industrial, and residential programs. So keep in mind, if your eyes don't have time to look at every number, they all are included in that meeting invite as well if you choose, or you can send a message our way as well. We'll go to the next slide here and look at our commercial forecast summary. So this slide shows a summary of energy savings and thousands of therms for some of our years being 2023 and 24, all the way out to 2045. So you'll see on the screen, there's 3 different sections for each of those years. That cumulative savings, which are those 4 different potentials that we looked at previously in our presentation. Then we also have the energy savings as a percentage of baseline. And then we also have incremental savings in thousands of therms for those same 4 potential areas. Keep in mind, it's going to be using the same reference baseline throughout all these scenarios. That's going to be the gas usage for our territory. We'll go on to the next slide here, please, Brian, and we'll showcase the top 10 measures. Once again, each of these charts that we're looking at are going to be for that scenario A, our 2023 IRP case. You'll notice the top 10 measures for this commercial area, about 77% of all the possible savings are represented by the top 10. It's almost 1 million therms, right around 930,000 therms in savings in the UCT area. Historically, the largest segment were boilers and insulation, while our new scenario, there's water heaters, furnaces, and insulation in the long run at 2045. You'll notice in the top measure charts that some of the measures reach 0 in savings by 2045. That's going to be for commercial and residential. It's prevalent as well. What that is because of retrofit measures like commercial boilers, for example, in this picture. They're on the council ramp rates that actually acquire 100% of achievable potential in a 20-year time frame. So actually 2043, they've been completely exhausted. So by 2045, the savings potential for those are 0, which is why you'll see 0% of potential in 2045. And that'll be on a couple more charts here coming up as well. Next slide, please, for industrial summary. Excellent. Fairly similar information, but you also might recognize the slightly smaller scale as well. So it's about 10% of the total cumulative savings of commercial industrial to 2045. It does not include transport. So you were looking at relatively small energy savings on a percentage basis, as well as a total overall thousands of therms, all the way across from technical through economic TRC and UCT potential. Then our next graph here, I should say next chart, will show the top 10 measures for industrial. Excellent. Fairly similar picture. Most of these represent, I should say that the top 10 here represents 79% of all the possible therm savings in 2045. It's approximately 50,000 therms. Interestingly enough, that strategic energy management makes up the largest portion. It's almost half, 37% total, and almost half of the top 10 measures here. We'll go to residential, please, Brian. Excellent. In our residentials, we are showing this cumulative potential forecast for residential. Very similar chart that we looked at about 5 slides ago. This is showing just for scenario A, the relationship between the achievable economic TRC potential, the UCT potential, technical potential, and then at the very top, as is normal, that technical potential. You'll notice that in terms of UCT, where we typically look at, they ramp fairly steady and then plateau right around 17 million therms in the years 2040 and beyond. A little bit of a more focused picture. We've got that forecast summary, similar information for residential. You'll notice that the reference baseline has been the same throughout all these charts. However, the actual cumulative savings are a little bit larger for residential compared to industrial and fairly similar compared to our commercial side of things, with the achievable economic UCT potential at that 12,000 mark in 2045. Then we can also see the energy savings as a percentage of baseline listed across those 4 different potential zones. In terms of top 10 measures, these actually make up about 95% of all the possible savings for residential. It's about 148,000 therms in 2045. This is where that phase out, or I should say, that 100% of achievable potential in the 20-year time frame through the council ramp rates, that's where it's really prevalent. You'll notice that the 3 items at the top here, direct fuels, the larger water heaters, I should say the smaller water heaters, as well as Energy Star clothes washers, make about 95% of all the possible savings for scenario A at the time frame of 2045. On the next slide here, across our commercial and industrial areas, we were able to compare all 3 of the different scenarios, what different forecast summaries are available, what type of actual measures differ across them, and they're quite similar across those 3 scenarios for, or I should say, for commercial and industrial. However, for residential, it was just slightly different, so we figured we'd bring it to our attention here. You'll notice that scenario B, the RNG future in the top there, highlighted. There's a little bit of adjustment in direct fuels and water heaters. It dropped in total UCT savings 10% to 7% and 7% respectively. And then actually in C, our RNG future plus gas bands, you notice that the Energy Star connected thermostats went up significantly, whereas in scenario B, they're much lower. Then we also have direct fuel furnaces and fireplaces coming up, which we haven't seen previously in our scenarios for residential. And then call it wrapping up this section, we've got a portfolio wide. So it's a combination of scenario A for our 3 sections of portfolio being residential, commercial, and industrial. Feel free to check out the actual chart on the screen. Some things that stick out, it's the fact that these top 20 measures make up 77% of all the possible savings of just over 1 million therms. Some highlight items like the Energy Star closed washers for residential, once again, commercial insulation, things like wall cavity, some other items like the furnaces for commercial make up a pretty large portion of these top 20 measures. And on the next slide here, if there's no questions about those scenarios, a couple of highlights that Monica can share about our next steps and action items.
Sure, thank you, Caleb. So you'll see EM&V operating under the biennial conservation plan here. Cascade's energy efficiency program is actually starting our pathway towards more robust third-party evaluation, measurement, and verification. So we just sent out an RFP a week or 2 ago and are awaiting responses for those who are interested in actually bidding on it. So I'm excited to see where that goes. And that's a measure level evaluation, measurement, verification. And then at the end of the biennium, I guess I should say, we'll have a full program, EM&V as well. And then we have our, as I mentioned, the conservation potential assessment is now run every 2 years. So we'll be working on a new CPA that we'll be completing next year in 2023. We're looking at those municipal gas bans. This will have significant impact on our programs. Exploring how this will impact and the assumptions we're going to have in the future. We'll, consider the scenario B and C was our start. We're going to make sure that whatever CPA, conservation potential assessment, we do in the future does take those into account because it's becoming more and more prevalent. And we need to make sure that we have a kind of a realistic view on what that potential is. If the new homes or new commercial buildings are not being built in some of these territories with natural gas, there is no potential there for us to save natural gas through these programs. So we need to make sure that we're realistic in the targets that we're setting, keeping those in mind. And then there's code impact as well. Code changes will continue to have a significant effect on our programs, particularly in new construction for commercial and residential. We're going to see how this plays out in the coming years. One thing that many of you are probably familiar with is the 2018 Washington State Energy Code for residential but residential building. That code significantly changed the uptake from builders on our energy efficiency program. So there's also a NEA study that actually came out just a couple months ago that addresses the current trends that they're seeing from builders using natural gas as well. So those types of code changes are really going to have an impact on what that potential is for those new programs. And we can incorporate that into the conservation potential assessments as we move forward. The last one did actually account for some of the code changes from that 2018 residential code update. And then the low income sector, we're going to have a continued focus on the at-needs community, especially the low income sector. As Lori mentioned, there's that position that's going to be posting for a manager to really focus on the low income, both in Washington and Oregon, as well as that offset program. One of the things we're excited about is being able to really look at that sector level breakdown that we have in our conservation potential assessment on income, so that we can, better identify where those customers are at and how to make sure they have equal access to the energy efficiency program. So that's something that manager will be able to really focus on a little bit more. And then we've got that special phrase that we've heard so often during COVID is adaptive management. Is really how are we post-pandemic? We're really going to need to focus on those program barriers. Maybe we're making our way through the pandemic. We're almost, I can't say we're almost done with it, but certainly it's evolved as we've gone down this pathway for the last couple of years. And right now we're looking at what are those program barriers, inflation, supply chain, labor for installs. We're anticipating these are going to have significant impact on the program for years to come, and needing to make sure that we're planning for what that impact is, and how to bounce back from some of those impacts. And then as far as just logistics, we're going to be working on the DSM chapter for this IRP within the next month or two. We're hoping to have that draft to the resource planning team in September. So probably not hoping, that's not the right word. We will have that draft in September. So yeah, that's our next steps. Any questions? You can go to the next slide, Brandon. It's just the question slide.
I forgot we had that question slide.
All right, so I guess I'm actually going to hand it to you then, Brian. You've got a couple of. Thank you. Thanks,
Yeah,
Caleb.
Thank you. Thanks, Caleb.
Yeah, thank you.
Yeah, thanks. Yeah, so I'll go on. I haven't seen any hands raised or any questions in the chat, so we'll move forward to the preliminary results. So we put together some preliminary upstream pipeline transportation results. So what we did is we wanted to take a look at just our upstream transportation. So we removed the emissions constraints, just to give us an idea of what we're looking at on our upstream transportation pipeline. So we run our analysis through Plexos, and we run it without DSM first to identify where our shortfalls are. And we identified some shortfalls in Zone 11, which is our central Washington area. It's up a lateral on Northwest Pipeline in 2034. And then in Zone Me, Washington, and GTN. So this is kind of and I'll remind people of the previous tag presentation, the flexibility of our transportation. We have transportation contracts that can drop gas off at certain locations. And in our Zone Me Washington area, we have a city gate that connects to a distribution system that has another city gate. And one of the city gates is connected to Northwest Pipe and the other one's connected to GTN. So we have flexibility of which pipeline to take the gas off of, which transportation contract to utilize. So we kind of combine that shortfall that we're seeing on that pipe, on that GTN pipe. So we have some shortfalls in the Central Oregon area, as well as the Zone Me Washington. And you can see that the max shortfall is about 7,000 on Zone 11, and then Me Washington and GTN about 20,000. And you can see the years that they start. They're pretty far out in the future. But once we input DSM, so this is the DSM results we get from Monica and Caleb, and then as well as ETO in Oregon. And the reason why these are called preliminary results is because we haven't updated the ETO results yet, so those numbers will change a little bit. But you can see once you put DSM in, demand side management actually delays these shortfalls about 11 to 12 years out. So Zone 11, you can see it moves out 12 years, and then the other zone, it's out 11 years. We wouldn't even see these shortfalls if we were still in a 20-year planning horizon. But since we're looking out to 2050, we'll have these, and we'll make sure to note them in the IRP. And then obviously there's no immediate action for these because they're so far out in the future. Anything can happen. Customer growth could be lower than we expected. It could be higher than expected. So we're going to continue monitoring these throughout the IRP processes that take place every 2 years. Some solutions that we consider for these shortfalls, targeted DSM. So we have areas of constraints. Maybe we can, if these shortfalls remain as we get closer to them, we could target some DSM in those locations. Pipeline expansion, if we can't get enough incremental DSM, we could look at a pipeline expansion if it comes down to that. If we deem hydrogen and RNG as being peak day reliable, so if we can have on-system projects that are reliable on peak day, those could be utilized to not have to use that upstream transportation. So that's also something we're considering. There's obviously a lot more, maybe some stuff that's not out there yet, and like Dan Kirshner had mentioned, some hydrogen stuff, anything like that. We keep it on our radar to make sure we're incorporating everything, and we're trying to value everything at the least cost. So base case modeling for climate coming back. And I do have to point out, these are not our actual results. As you saw in slide 26, the differing policies between Washington and Oregon, there was a question mark on RNG attributes, which is this blue piece. And you can see that that question mark is a pretty big question mark here. There's also some questions about allowances. So we feel pretty confident about the no cost allowances that you see in the gray. Now the question is, how much is there above and beyond that in that green area? So that's something that we're still considering, we're still looking at. That's what the scenario modeling will be doing in tag 5 is doing some uncertainty scenarios with allowances and RNG. But just to touch on each of these, and these are kind of just a reminder of what Abby went through, but we have these no cost allowances in Washington. This is where we are given allowances, we put it up for auction, we have the ability to purchase those back. And then there's allowances above and beyond that in that green area. So going back to the top, that black line, that is our baseline emissions that we forecast. So that's including climate change. And then in that orange, I'm bouncing around a little bit, that's where we have our expected energy efficiency. So that's the energy efficiency that we got from Monica and Caleb's team. And then there's in the yellow, we have optimal incremental energy efficiency. So this is above and beyond energy efficiency than what we would expect based on our avoided costs. So if we can go out and get more DSM, that's an option. And then we have, I mentioned RNG, and then we have incremental RNG in that purple area. And like, can't remember who mentioned it, but even if their RNG attributes aren't available, there are RNG attributes as long as we're purchasing that RNG as well. And then obviously there's optimal hydrogen as well. You can see it starts in 2025. In this graph, we're expecting it to probably start a little bit later than that, but we plan to have more finalized results at tag 5 with a lot more scenario and sensitivity analysis around this. But we just wanted to give everyone an idea of what it kind of looks like, what options are out there. Are there any questions? Is there anything, Devin, did you want to add anything, or Abby?
No, I think you handled it great, Brian. I think, yeah, the biggest emphasis, like you said, these really are just example results, right? Something that we wanted to show a potential resource stack that we could look like. We're not committing to saying we're definitively going to acquire that much incremental energy efficiency, or we're budgeting for the gray amount of hydrogen. This is just from some modeling exercises that we've done in the past, a theoretical result just to show what some of the kind of resources and a general scope of what could be the magnitudes that we might be looking at.
see any questions. Yeah, I think the next we'll just jump into distribution system planning. I think Kathleen, you're going to take over the slides.
Yes, that's my plan.
Okay. I will stop sharing so you can share.
All right, let me get set up. One sec. Right. Share. All right, we'll get going. So I'm going to cover distribution system planning. Again, I'm Kathleen Campbell. I'm senior engineer in engineering services. This will be a little bit specific for Washington when we get into projects, but very similar presentation will be the front end for Oregon, but we'll just have Oregon projects. So first I'm going to cover what I'm going to go over. So this presentation will cover distribution system modeling process, our identification of our system deficits and constraints, what we're going to do about those deficits, so enhancements and reinforcement options to address them. And then we're going to go over our enhancement review process and how we select into the capital budget. And then with that, we're going to cover our projects that are in our current IRP, so 2023 to 2027 capital projects. And then I'm going to finish up and just touch on this briefly at the end. We'll talk about the iterative process of the IRP. And then we'll open it up for questions, but feel free as we go. If you have questions, let me know. I can't exactly see my screen, so if we have questions, just let me know, guys, on the team. So we'll start with distribution system modeling. Before we get into modeling, I just wanted to quickly familiarize you with our system. So we operate over a range of pipeline diameters and operating pressures on our systems. This is just a brief summary of what we have. In addition to piping, we also have facilities we operate. They include reg stations, valves, and other equipment, heaters, odorizers, compressors, all part of our system. So before we get too far, I wanted to go very high level on system design and what we have. So when we talk about different things, high pressure versus distribution pressure, what a gate station is. So I wanted to briefly go over that with you guys, but up to this, I know we've covered that Cascade gets their gas from two interstate pipelines. Williams is one and TransCanada is the other one. So at those facilities, we, have gate stations with those pipelines, and at the gates, we take over custody of the gas. So they basically start our system. At the gates, we odorize the gas and typically cut pressure. And then directly downstream of our gates, we have high pressure lines. So these high pressure lines, typically are defined as they operate over 60 pounds. Each system and lateral is unique, but on high pressure lines, they typically do two functions. They can serve our large volume customers directly. That would be things like customers with elevated delivery pressures, like cogens, oil refineries, large customers that need higher pressure for the processes. And we also use our high pressure to cut pressure for our distribution system. And those facilities are called regulator stations. So the high pressure in this map is green. And then blue is our distribution system. This system typically operates below 60 pounds, and it's typically what we serve most of our residential and commercial customers off of. So that's just kind of a summary. As we start talking, system deficits and enhancements and things, just understanding some of that language, I think will help us out in the presentation. So to do all this, we use a gas modeling software called Synergy Gas. We have a lot of capabilities with Synergy. We use those models to model out growth and identify our deficits. Synergy Gas is a hydraulic modeling software. allows us to predict flows and pressures on our system based on our gas demands that are predicted during a peak weather event. With that, we build our models and we incorporate our total customer loads and our existing piping and system configurations. Synergy Gas is supported and distributed by DNLVGL. And with our models and part of our Synergy Gas modeling process, we rebuild our models every 3 years. And then between rebuilds, we maintain our models. And then I'll also mention that all of our models, we have individual models for all of our Cascade systems. And they include our high pressure laterals, our distribution systems, all of our larger diameter pipelines. So I'll just give a quick example. This is a GIS screenshot of Kennewick. So this is just GIS. You can see, I see a couple regs, I see a couple high pressure lines and some distribution system, but basically we just build these in Synergy. So some nice screen effects. But you can see that system, it's very representative of, direct from GIS, exactly, all the infrastructure in our systems. And again, I'll mention, all of our systems are unique in their customer served and their pipeline characteristics. So when we get into model building, like I mentioned, these are done every 3 years and updated. And when they're rebuilt, we bring in, all the current GIS data to build the spatial models. We also export in all the current CC&B billing data that goes to a Synergy module called CMM, which stands for Customer Management Module. And this helps us create our demands file, so our usage on the system. Each one of these models, we validate and calibrate, once they get built to make sure that they're performing, to our actual system. We go through model validation and calibration. And how we typically do that is we'll simulate a low pressure event, on our system. We'll dial in the heating degree day and look at our system, how it performs, and we'll compare it to actual data. So we have lots of data on our system. We have ERXs, pressure charts, SCADA, Metrotech, and our large volume usage from gas control. I heard someone on. Does someone have a question so far?
This is Heidi Caswell. I do have a question. Thanks, Kathleen. Could you help me understand what the time granularity of the billing data is that goes into CMM, and how precisely that's reconciled against the temperature data?
Yeah, I'm going to get into that in a little bit. I'll give you a little more insight, and I have a couple screenshots. But yeah, so in CM or CC and B, we take the monthly data, the monthly billing data that we get, and we convert that to peak usage. And there's a little bit of a process, and I have a slide in a bit. We'll go over that.
Okay, super.
Other things
Thanks.
we're looking at, is fixed networks, and another tool that's kind of being developed. So.
Yeah, if you're answering it in the future, then I apologize for disrupting.
Okay, yeah, let's follow back when I get to that. We can talk more on it. So yeah, so we calibrate the models. We'll keep going, and then once we have these calibrated, we then ramp them up to our design day model. And our design day models are peak weather events. It's the coldest day we expect on our system based on historical weather trends. And engineering, we get that from regulatory. So yeah, so that's part of that process. And then whenever we build models, so I just wanted to briefly touch on model validation and calibration. A best practice is to get models, to be within 10% of the actual data is a good best practice for modeling, and a goal we always have is that's how accurate we want them. And then another note is we did all the Cascade models were rebuilt in 2021. So we have pretty, we're on the newer end of our cycle. So now to help understand this, and this is some of the slides I was talking about, we'll talk a little more about data gathering, and I have a couple visual slides on this. So this is just a screenshot of CC&B, which is the monthly billing data we have. Like I said, this goes into CMM, and then helps us predict our peak usage, which there'll be another slide on. Other data gathering is I just put a screenshot in of our SCADA data. So this is some of our gate flows and large volume flows that we have through gas control, and we have real time and historical flow data on our systems. So next up, we talked about this one a little bit, but this has to do a lot with the peak day. So I wanted to share what our heating degree days on peak, our peak events are. Also, we call it our design day models. So you can see that the diverse range of areas, have different low pressure events. So you can see our heating degree days we use, and then what temperature that relates to. And everything is kind of in relation to 60 degrees, because that's typically when consumers turn their heat on. It gets chilly, and you typically want to heat your home at that temperature. Going. So CMM, this is kind of that program, and this is just a little screenshot, but the CMM brings in the CCMB data, and it basically helps us make the demands files. And these demands files are applied spatially where they're located in the model. So it's part of our model building process. And this is the one I think you wanted, Heidi. But yeah, so this talks about our calibrated versus peak degree day and kind of the process. So basically this relationship's linear. As it gets colder, as the degree day ramps up, people's load goes up. So we see more, more gas usage. It's colder, there's more more heating that needs to happen to keep your house warm. And then with this, so part of what we're talking about, so this would be our calibrated degree days. So this is, we typically like to look back not too far, because we want to make sure it's a recent cold weather event. So we'll find the coldest weather event we've had in the last year or two, and we'll use that as a calibration day. So this one, for example, is a 40, and then we can get how much usage there was, and check it, and check our pressures, check everything in our model, with the goal of being within 10%. And then with this, we then, for design day, we ramp up to a peak heating degree day. So this linear relationship lets us predict, based on the, the historical weather trends, dial in that degree day as our peak day, also known as our design day. So this is kind of the ramp. Did you have a question on this, Heidi?
I was just reflecting on the 60 that you were using, the temperature basis of 60, and I thought, and I did just check, and I'm finding that it's 65 degrees Fahrenheit. So what effect would that have on your model?
Yeah, so Oregon and Washington, I guess our regulatory group's done a lot of studies. It is typically 65 for industry, and our other states use 65, but for Oregon and Washington, we use 60. It doesn't have any effects because the actual temperature, they give us an actual temperature. So whether you relate it to 60 or 65, the temperature is still the same. Does that make sense?
So you're actually making the translation in the synergy model to get to the right temperature.
Mm-hmm. Yep.
Okay, thanks.
Mm-hmm. But yeah, and so I'll also mention, like, some of our CMM data we use, we determine our usage per customer, because we build our models for certain areas, our usage per customer can vary, in the models geographically. It can be based on consumer behavior, energy efficiency programs, building code standards, the vintages of the homes. There's lots of things that goes into their usage that's kind of captured in CCMB, industry trends in some areas, maybe it's been popular for people to get generators, or there's been some incentive for them, or I know in like the Bend area we've seen a lot of additional housing units where they're putting apartments on top of their garages due to density, due to high high real estate values, popular areas and downtowns. But yeah, we can move on. So all this kind of helps us, once we have trusted, models, that we then can use them to identify our system deficits. So we spend a lot of time and money on the synergy models, and I just want to go through our capabilities. So, with these models, that are calibrated, we can review large customer requests. We can model RNG with them. It supports our design and sizing of pipe and pipeline components, lets us do future planning, lets us model IRP growth, helps us. It's a tool to identify our deficiencies. We can use them to determine system reliability. Could be a gas emergency or, some system we need to shut in. We use the models for that. And we can optimize our distribution system enhancements with them. So lots of tools, and Synergy is a great resource. That's why it's really important to have it really accurate. So now I'm going to get in a little bit on what a capacity deficit is. So a deficit is defined as a critical system that is at or limiting capacity. And then I'm going to give you guys a couple examples of what these are, because this is really what we talk about, when we propose a reinforcement, it's to address a capacity deficit. So pipeline bottleneck, this would be pipeline that just can't support flows. So as pipelines get more flows, more demand, due to growth over time, they'll have flows beyond what they're designed for. And when pipelines see those higher flows, you'll see higher velocity, which equals higher pressure loss. So it can lead to bottlenecks. If you have the straw scenario, you can only, put so much, through a straw before it's constrained. Other things with our system is, we have certain operating pressures and things we need to maintain on our system. So one example of this is if we have a 200-pound high pressure system that needs to cut to a 60-pound distribution system. If my 200-pound system at the end of the line only has 40 pounds, it's compromised my 60-pound distribution system. So that's one example of end-of-line pressure that doesn't meet the next system's design. Another example might be not meeting a required customer delivery pressure. So at Cascade, we have a lot of very large volume customers, and we have contracts, and some of them have pressure requirements. For example, a PSE Fredonia is a big cogen on our Anacortes lateral. That customer has a contract pressure of 305-pound inlet. If we cannot deliver 305 pounds, their cogen equipment cannot operate. So that could, not meeting customer delivery pressures could be a constraint for us. And then it can also just be as simple as a component. So regulators, compressors, certain components, including pipe, have certain capacities they can safely deliver gas at. So as those, if it's exceeded, then it would limit and potentially be a capacity deficit. Keep going. So with this, and this kind of builds into our IRP process. So we use, our distribution system, our modeling process, and with the IRP, we do a comprehensive review of all of our systems. And with the IRP cycle, we review these every 2 years, with the goal of identifying the deficits and proposing reinforcements or betterments to address the deficits, to make sure we can maintain reliable service to our customers during the peak low weather events. In addition to that, we also review, we're constantly, every year we do a capital budget. So within our budget cycle, we also review, all of our reinforcements at that time too, on an annual basis. So anytime we have a deficit, we evaluate it and we'll propose a reinforcement. And typically that proposal will be based on alternative analysis, and then it'll be placed into the capital budget based on the timing needs of the predicted deficit. And we'll get into this a little bit more. So now I'm going to cover some distribution enhancement reinforcements to address the deficits. So we're progressing a little bit. So enhancement options. So we talked about what deficits are. So now we're going to talk about like what solutions we can do or how do we fix these, you know, and I want to go over a couple things so we can talk the lingos. So with pipelines, enhancement options would be replacements, reinforcements, loops or backfeeds. You know, we could do pressure increases or uprates. You know, with facilities, you can always upgrade a facility. Maybe the whole facility needs to be upgraded or maybe certain components. With distribution systems, you can always add additional regulator stations, you know, to feed the distribution system. You know, additional reg stations would get more flow and pressure into the system. Another option we can do is we can always add gate stations to our system. And there's always potential for compressor stations on some of our higher pressure laterals. Like I said, I think I've said this before, but you know, all of our systems are unique and each one will be optimized with a different solution. You know, some of these solutions wouldn't be feasible for every scenario. For instance, if we're in the middle of a distribution system in a downtown setting, it's unlikely we could put a compressor station there. So they're all a little different and unique for each one. But we can look at one. So to get us thinking, I threw in a distribution enhancement example. So this is a town in Synergy. We can see some low pressure here. So 10 pounds on the map, kind of in the southeast corner. You can see the red. And I'll give you a little more background on this one. So I'll let you know let's say there's growth happening in the southeast. Let's say some farmlands being converted to developments. So residential homes are going in and we're expanding. So we see this pressure concern, and you know, with more growth happening, we predict, you know, worse pressures as that growth happens. So we've identified a deficit, you know, with the concern that, you know, we could lose pressures to these homes, you know, as more homes grow out. We have a compromised system, you know, a deficit. So what do we do to, you know, address this? Look at a couple options. So, you know, do I do a compressor station? Do I do pipe? You know, we go through that slide I went over. You know, do I do another reg station? What do I do? So here's some regs. I can see over here, I'll put my mouse on here. I only have one feed that's going over. So I can, you know, you can see this is disconnected, I guess. You know, here's some pipe. Those look good. Let's see. So the first option, that first pipe looked really good until I found out it was in the middle of an airport. So you can see on the back of this, you know, aerial map, you know, some reinforcements look good, but you have to have a feasible and constructible pipeline route. You know, going through an airport's not feasible. So I'm going to throw this option out. And then I like the second option. So this one I kind of skipped ahead. Keep this brief. But this is after this reinforcement's done. This is kind of my pressure gain. So all my pounds are over 10 pounds. You know, we're looking good. We can support the growth we predicted in this model for this area with this enhancement. You know, and a lot of solutions, you know, will really depend on how much growth we're predicting. You know, in the 5-year cycle, you know, we always want to be able to support growth, but we don't want to overbuild our systems. You know, things can change on the system, you know, and may change over time. So in this example, you know, maybe there's something economical, you know, where the development doesn't happen or it cools down, you know, or maybe there's farmland and maybe all the farms that are going to convert, you know, have converted already. Maybe there's, you know, the next farmer that owns the lot. Maybe they're going to keep it as farmland. You never know. There's just a lot of drivers economically, you know, on this. So we don't want to overbuild. And that's kind of part of the point of the IRP is, you know, looking at these, assessing it, you know, meeting growth over time.
So Kathleen, you also take a lot of loss through that one section that comes just south and slightly west of the gate of the reg station. Would you have looked at replacement of that section as well? It looks like you have that happening on both of those southerly segments.
Yeah, I got a slide where we're going to talk. Yeah, we're going to talk through like how we go about, selecting our enhancements. So yeah, in
Okay,
this one,
great.
and we would have went through alternative analysis and gone through, ranked them and gone through that. But I'll cover that in a slide. But this is just to get people's brains thinking, when we talk,
Okay.
deficits and what we need to do to fix them. So this is just an easy example.
Right. I was just on it because you were already putting other pipes in the ground. So sorry, I was jumping to solutions too quick.
Yeah. But yeah, so this is where I was going. But yeah, so our enhancement considerations, on each one of these, we'd look at scope, cost, the capacity increase, timing, system benefits and alternative analysis. Each enhancement, like Heidi's talking about, we'd have different pros and cons for each one, and we need to weight them out in alternative selection. I'll discuss more on that and more on those processes in a bit. But like I mentioned, there's several things that would play into why an enhancement selected. Like that example we went through had permitting in the airport, but there's just different things that can constrain you. So with that, now I'm going to go a little more into our enhancement review and our selection process. So this is the slide I was going to get at, but these are our general guidelines on how we kind of select reinforcements. So typically we want the shortest segment of pipe that addresses the deficiency. Sorry. And then, we also want, the enhancement with the most favorable construction conditions, most favorable environmental conditions, and, with consideration to impacts to the community. We'd also look at routes, you can always install pipe in place, but there might be opportunity for you to run pipe in a new area and maybe get new potential customers, that hadn't come on because there wasn't pipe in the area. So that's things we consider, and that's kind of what I wanted to get at, Heidi, what you were asking, because replacing pipe where you already have pipe, or running a trunk line when I already have, let's say a 2-inch line running down a street, you might have more opportunities, running in a new area. We also want to look at construction cost, of course, including restoration. Other things we consider, we generally want to minimize, water crossings, railroad crossings, and highway crossings. And some of the things with impacts to the community, sometimes a route, might be the shortest length, but, there might be a road moratorium with the city where, we wouldn't be allowed to get in there for 5 years. Some cities have 5 or 10 years moratoriums, so you can't even construct, or you're basically rebuilding the whole road for the moratoriums, or just community impacts. But yeah, and then to build on that, we'll kind of go back over, but we'll go through these blocks a little bit, and this is a little bit internally how we take all this information in and make decisions and get it into the budget. So we take all our IRP growth data, we got our design data models that are calibrated, and for our peak weather events. And then we also get information from our districts and our local personnel, what's going on with city projects, new housing developments, etc. And we take all that in and identify our system limitations, so our deficits. And then with that, we go through the process, and a lot of times engineers help with this. So our engineers do the modeling, but they'll then also propose reinforcements, and as they work through their reinforcements, they'll go over benefit, feasibility and cost on all those. And typically, the engineers will work collaboratively with their managers and directors, to review all the reinforcements proposed and help prioritize them. So that's kind of the next step on this, is project rank. We rank them based on priority, based on need. So timing on when it needs to happen, when we predict the deficit will happen on our system, kind of dialing in that, and how all the reinforcements, what's the highest priority, what's the biggest risk, because we want to minimize those impacts on our system. And then once all that gets taken in, we'll get them scheduled into the budget. So like I mentioned, it's pretty iterative, our process. So anytime information changes, we will make tweaks to the capital budget as needed. Currently with our capital budget, I'll let you know, we're in our capital budgeting process. And so for us, we typically go through our first revision of the capital budget in June, and then it goes through a couple iterations, and then it'll be approved by our executive team, typically around November. And so our budget goes January through December. So that's kind of our process. So right now we're working through a couple revisions. So a lot of these discussions are happening right now on priority, and we're asking, can it be pushed off? Does it need to be done? Those questions are all happening right now, actually. So all the projects I'm going to share with you are based on our first revision. So it could also, by the time November comes around or what gets approved, they could change, but it's kind of just a disclaimer at this point. Things are changing. It's just iterative information, that we'll make tweaks on. But yeah, so with that, we'll now get into our projects. This is the fun part, talking about projects and what we have planned in our 5-year IRP. So these will be projects 2023 to 2027. So in this one, I'm going to give the disclaimers. I'm just going to cover Washington projects. This is Washington focused. In this presentation, these are the projects we'll cover. These projects are going to be covered because we're going to cover projects over $1 million. So our larger projects. Each one of these projects, we're going to go over scope, cost, timing, benefits, and alternatives considered. So I'll talk about each one a little bit. What the deficit is, how the reinforcement addresses it, and timing. Some of these you may have seen them in past IRPs. So some of these were in the 2019 IRP, but that's the point. When this cycle rolls around, we want to relook at them, reassess them, ask the questions, were these projects that, we identified, 2 years ago that were prioritized 3 or 4 years out, are these still needed? Yes or no, or can they be pushed out? Has something changed on the system? So that's what we look for, and I'll go about the IRP. So yeah, I think I'll get into projects. Our first project's Kitsap Phase 5, pipeline reinforcement. The scope of this project, it's 4 miles of 12-inch high pressure. Due to the essence of time, I don't think I'm going to read cost out because they're on the slides and in the PDFs. I think it'll make us move a little quicker. So this project, we're looking at timing in 2023 design and then 2024 construction. So I'll give you a little background on our Kitsap lateral. Our Kitsap lateral runs from our McCleary Gate up to Bremerton. It's a large lateral that basically serves gas up the Bremerton area, Bremerton-Silverton area. This is the last phase. So over the last 15 years, we've been doing these phases. This will actually complete the 12-inch loop. And this section, phase 5, is just north of Shelton. So it's kind of actually a middle section in the loop. And it'll connect to phase 4 and phase 3. And since it's been going on a while, no alternatives were considered on this one because it just supports our long-term planning. It's been, something that's been in the works for a long time. Next up, we got our 8-inch high-pressure reinforcement on Basic Boulevard. This is a 12,500 foot at 8-inch high pressure with a regulator station. This project's mainly to address distribution system pressure issues in Aberdeen. So currently Aberdeen's served by one regulator station on the north end of town. This project's going to provide a second feed into the center of town. So the west side will get fed with a new regulator station to get more flows and pressures into the distribution system. Timing, we're working right now on 2022 design and permitting with the goal of 2023 construction. Benefits, like I said, it'll provide a redundant feed into the Aberdeen distribution system, so a second regulator station. alternatives considered, we did look at this. For this project, we would need to be equal to the pressure gain we see, we would need significant distribution system loops and reinforcements to match it. And I actually don't think they can quite match what this project does. Keep going. Next up, we got the Elma and Satsop Gate Station. This is over in the Aberdeen district. Scope of this project, it's a new gate station that'll be a second supply source to the Grays Harbor lateral. A little background, our Grays Harbor lateral runs from McCleary to Aberdeen along Highway 12 for 40 miles in length. This high pressure system has pressure issues at the end of the line in Aberdeen. So this gate is going to help get flows and pressures down the lateral to help the end of line pressure issues. Timing for this project, looking at 2024 design and permitting and 2025 construction. Benefits, like I mentioned, it's going to address our high pressure issues at the end of the line in Aberdeen, and it'll provide redundancy to the McCleary Gate.
Question for you, Kathleen. Sure. This seems like a particularly interesting location. Have you ever done any transient modeling of something like this as well, using Synergy's transient module?
Yeah, we have some USM models on our systems. Yep.
It feels like this is an area where, you know, given the length that you're talking about and the pressure losses that you're talking about, that it might be an interesting application of something like that to determine, you know, is the kind of like the amount of time at which the system is at risk, if you will, or for which the system is at risk.
Yeah, with line pack and things. Yep.
Exactly.
Yeah, we're working. So we have a couple USM models in Idaho we use. We use them on some of the larger laterals with compressor stations we have them. This lateral, it's kind of, I guess we're developing some of those models for Cascade too.
Yeah, it just feels like 40 miles has got some line pack in it, right?
Potentially, yeah. But yeah, we see I mean, I know I've seen pressure charts, so we know we have the pressure issues at the end of the line. Also, you know, there's a couple ways you can see it even without the USM. You
Sure,
can see it
sure.
in your pressure charts, you know, which reduce, you know, you'll compromise your rate capacities and things as those pressures get drugged down at the end of the line. But yeah.
Yeah, I was just wondering the extent to which that model might be used in a case like this.
Yeah, by the time this one's a couple years out, I think we'll definitely have that model by the time this one goes. So it'll be something more assessing. I actually worked on this one, so this is actually one of my projects. But yeah, we've looked at the Grays Harbor lateral's been an issue for a while. There's been a lot of like large volume interest on it, people wanting upgrades, etc. It's been pretty vetted. But yeah, so with that, alternatives considered is, you know, to this, whenever you have pressure problems, you know, adding gates one option for a betterment, or you could reinforce or replace the Grays Harbor lateral. You could do bigger pipe out of the McCleary Gate to also get more flow and pressure down the lateral. So yeah, and with this, I'll note we haven't gone over a gate yet. So typically on gates, we have Cascade cost, and this is the cost for Cascade to, you know, put our station in, you know, regulation, odorization. And the Northwest Pipelines, they have cost too, because they'll have a tap on their pipeline and then a meter, you know, and they'll have some piping too on their end. So that's kind of the cost breakdown when you see gates. We'll keep going. Now I'm going to talk about the Bellingham 6-inch high pressure reinforcements. This is on Medore Avenue. So this project is 2,500 feet of 6-inch high pressure. This project's actually a replacement also. So this project's going to be 6-inch high pressure that's going to replace 4-inch high pressure. And the main concern or the deficit on this one is We have low inlet pressure to R5. So R5 is kind of the end of a high pressure system that has low pressure, and that's compromising deliveries at R5. And R5 is a major feed that serves gas all the way to Sun Valley, if you're familiar with the Bellingham area. This one, we're looking at 2022 design and permitting. I believe it's in progress, and then 2023 construction. An ancillary benefit to this one is, since we're replacing existing pipe, it will eliminate an above ground bridge crossing that we'll drill with the new pipeline. And this one, for alternatives considered, I'll give you a little background. This is in a challenging area. There's actually no alternative route with comparable cost. There's road limitations in this where this project's at, which is why we're replacing it in place. There's not a lot of roads that run east and west due to I-5. And you'd also have to move R5, and it would cause you to actually put significantly more pipe in. So we've chosen the same route for this upgrade. Get into the next one. So this is some Richland high pressure reinforcements, and this is kind of a two-parter. So we're going to do Richland 12-inch high pressure phase 2, and then we're going to do a Richland wide gate upgrade. These two projects go together because we're going to take the existing Richland Y gate, which basically serves a small isolated section in our distribution system, and we're going to upgrade it. And with that, out of the Richland Y gate, we're going to run the phase 1 and phase 2 12-inch to tie on to our Richland high pressure lateral. And some background on this is our 8-inch high pressure in Richland that extends all the way up to the Hanford area is at capacity. It can no longer support growth, and we've been seeing over the years industrial growth in North Richland. This lateral can't support that. So these two projects are going to help fix those pressure problems, drive flow, to the end of the line. Phase 1, I will note, is being completed this year. And then phase 2 is 3.7 miles of 12-inch high pressure. It's looking for at 2023 construction. And then the gate upgrade, we're looking at designing it this year and then constructing in 2023. So these two projects combined solves our capacity deficit in Richland and provides a backfeed to the Richland high pressure system. And I'll give a little more background on the Richland high pressure system. Our Richland high pressure system is fed from our Kennewick gate and our Southridge gate. So it's a pretty long stretch of pipeline that runs all the way up to North Richland. So where this Richland Y is going to interconnect is near the river, and it's almost in the middle of that pipeline. So it'll be a new source in the middle of the pipeline to help meet demands in Richland. And then, so one alternative with this, so I had to give that background, is so the alternatives considered for this one, and this one's been kicked around a lot over the last couple of years. I know I worked on it back, I was the Kennewick engineer several years ago, but the alternative is you could upgrade the Kennewick gate and replace the 6-inch Richland high pressure lateral that runs on Clearwater and Columbia Center. But that's a very challenging route since that's a major feeder in Tri-Cities. Maybe be very expensive. So that's actually why we went through looking at this one. This project was chosen over that. And then really, since you'd have a gate upgrade either way, the gate's kind of a wash. If you could upgrade either gate, they'd cost the same. So the pipeline is kind of what makes the difference on this one. Keep moving. Next up, we got some South Kennewick reinforcements. This is distribution system enhancements. We have low pressure over on the south side of Kennewick. Just kind of happened over time with growth over the years. This project's going to bring in a new gate station. It's going to be called the South Kennewick Gate. And then out of that gate, we're going to run 8-inch plastic reinforcement that'll consist of 2,500 feet of 8-inch. This one, we're looking at 2024 construction on both the gate and the pipe, with the gate being designed in 2023 and permitted. So benefits to this one's going to solve our low pressure issues in Kennewick and continue to support growth. And alternatives considered. We did look at this. So in Kennewick, we have a lot of isolated pipe, a lot of homes. And I don't know exactly the dynamics on it, but they just didn't all go gas. So Kennewick's distribution system's kind of isolated. It's not, there's like pockets of gas. So to really boost pressure, you'd have to do significant amount of loops. And with that, those loops were just favorable as this solution. So, and kind of where this is at, I'll give a little more background. This is on Olympia Avenue near the Williams pipeline, and it'll run on Olympia Avenue into our distribution system. We'll keep going. Next, we got Pasco, 6-inch high pressure reinforcement. This project consists of 5 miles of 6-inch high pressure, looking at 24 design and permitting and 2025 construction. So currently, I'll talk a little bit about Pasco and give you some insight. So we have a gate called the North Pasco Gate. That gate's currently at capacity. Had some pressure problems over the years at it. And also the high pressure system's compromised. It's basically at capacity. So it can't support growth anymore. So to fix this, instead of upgrading the North Pasco Gate, we've decided to run and tie the Pasco system into our Burbank Heights Gate. Burbank Heights Gate is located in North Pasco, and it serves our Atelia lateral. Familiar with that one? And so that gate has capacity. So instead of upgrading a gate, we're choosing to loop in the Burbank Heights Gate. And part of the reason the Burbank Heights Gate has a little more capacity is we, a couple years back, we completed the Wallula Gate upgrade. So we put a backfeed on the Atelia lateral. So we're kind of shifting our capacity. As the Burbank Heights Gate, we can pull that into Pasco, into the high pressure system. Another reason, so kind of with alternatives considered, so like I'm talking about, your alternative to this one is you could upgrade the North Pasco Gate, and then you could reinforce high pressure out of the gate. But that alternative was not considered due to challenging cost and pipeline route. So the North Pasco Gate's right off Road 68, and it's very challenging. And our high pressure runs on Road 68. If you know the area, that's kind of by the airport, a lot of hotels, restaurants, Lowell's, a very major feeder for Pasco. So very challenging to put a pipeline in that Road 68. Yeah, continue. So next up, we got the Burlington South Feed reinforcement. This project's 15,000 feet of 6-inch plastic in a rake station. Timing, 2022 design and 2023 construction. This project's to address distribution system project due to some low pressure issues in Burlington. What this project's going to do is going to loop the system. So Burlington's another one that currently has a single rig feeding the town. It's in the north. So this project's actually going to use an existing rig that has some capacity that's over to the west side of Burlington, and it's going to tie the system in and loop it. So the 6-inch poly is going to be a trunk line from that regulator station into our distribution system to boost pressures. So an alternatives considered, something we did look at is we could have, instead of plastic reinforcement from an existing reg, you could always put some new high pressure in with the reg station, with additional loops. But that wasn't chosen since the route wasn't as feasible, and high pressure typically costs more money than distribution pressure. So anytime you have steel, you have welding, NDT, more cost compared to plastic. Keep going. Next, we got the Wapato 4-inch high pressure replacement and reinforcement. So this project is in Wapato. It's going to replace 31,000 feet of 4-inch high pressure with 6-inch high pressure. Timing, 2022 design and permitting, and 2023 construction. So a little background on this one is our Wapato line is fed from our Zilla Gate, and our Zilla Gate Downstream of that's our 6-inch Zillow top finish transmission line. And so Wapato is kind of on the west end of that system. So from Zillow, we run into top finish, and then the line splits. One goes east into Granger, and then this line goes west into Wapato. And currently this 4-inch line's at capacity. It can't take any more capacity. For Wapato, it's compromised. So with this, the benefits of this project is going to address, in addition to getting capacity, it's also going to address our MAOP concerns. So this line was part of our, I guess, settlement agreement. You know, we needed to get some high pressure records. So replacing this line will accomplish those goals, and it'll provide capacity to Wapato. Alternatives considered, this is another one of the projects I worked on. We did look at backfeeding Wapato, maybe putting a new gate near Donald, which is to the west, and running a new high pressure line into Wapato. But this, since it would require a new gate and it was a pretty challenging route, had significantly higher cost. Even though we love backfeeds, we have to ask the question, you know, what cost do we do those at? Right now, gates, you've probably seen on the slides, they're running $3 to $5 million. So that was a limitation on this one. So we have chosen to replace and also meet our MAOP goals.
What is it, Kathleen? Can you explain what the MAOP settlement was that you were dealing with?
Yeah, so our MAOP group works on this, and it was with the state of Washington. We have to address all of our high pressure lines by a certain time. We had so much suspended penalties, and then we have some other penalties that are contingent on us addressing it in the timeline. And others, feel free to chime in. I used to be in that group, but I haven't been directly involved in that in a couple of years, so I might be rusty. But we got to get all the high pressure records. So pressure test, all the records is basically what the settlement is. So our MAOP group, we're actively doing work, and we get some rate recovery on it to get the records we need on the lines. And some of the lines we can pressure test, or some will, you know, we have to replace, you know, or we can test for wall and grade. You know, there's different things. Each pipeline we've looked at, you know, come up with the best solution to address that. And that's in our system integrity group.
Okay, thanks.
Mm-hmm. So yeah, and with this, and I just want to expand a little bit on the Wapato. So with Wapato, part of the reason it's a challenging route, I just want to give a little more background, is we'd have an I-82 crossing, and then we also have a Yakima River crossing. You know, if we were to do this new gate, this backfeed from Donald, and then it's also in tribal land with Yakima Nation. So that route is considered to be unfeasible for us, because we've had it's been challenging for us to permit with Yakima Nation. But yeah, so that wraps up projects. Got a lot of good ones on the plate that we'll be getting done in the next couple years to handle all of our deficits. But now I just want to talk about our iterative process of the IRP, you know, and how we assess. I think I've hit on this. I don't want to hit on it too much. But, you know, kind of our process is, you know, we're constantly looking at our system, you know, and proposing these enhancements or reinforcements to address deficits, you know, with the goal of, you know, picking the best long-term solutions for us, you know, to address the deficit and address it, you know, when it needs to be addressed, you know, make sure the timing is correct. So with the IRP, you know, every 2 years we do this, so you'll kind of see this overlap is what this slide's kind of showing is, you know, projects that are, you know, right now we're talking about that are looking at 2025, you know, we'll be re-looking at those, you know, in the next IRP and asking questions like, are those still needed? You know, has something changed on our system? You know, if, let's say RNG comes on, maybe that addresses some of that. Maybe some of our capital budgets changing, you know, to account for that. You know, and I also wanted to point out the importance, you know, a lot of these projects, they can take multiple years to complete. You know, you can see, you know, we're beginning to get more common in doing design and planning, you know, the year ahead, you know, with giving us a full year for construction. So some of these larger, bigger, more challenging projects, you know, just permitting and everything going on, they take longer to get for us to get them in the ground and in service. So with this 5-year cycle, you know, this process allows us enough time to plan and design and then construct these projects to address the deficits, you know, which allows us to be both proactive and reactive to our system deficits, you know, and really helps us ensure safe and reliable service to our customers. So yeah,
And
so that wraps me
Kathleen,
up. Yeah, go ahead.
just a quick question. So the target is to basically outline the next 5 years of capacity deficiency items that are highly probable. Is that what the target is, or what is the time frame that you're really focusing on?
Yeah, so each of our IRP is like a 5-year focus for distribution system modeling planning.
Okay.
And then really it's our, you know, we're really, you know, if we're divided up like the 2 years that are upcoming, you know, would be our main focus, you know, but then we're still looking out or planning, you know, so we're getting those projects in the budget identified, you know, in the 5-year. And then we'll look at them again and scrutinize them some more, make sure they're, you know, what's best for our customers.
Thank you.
Yeah, any other questions? We'll open it up. If you have any project questions, feel free. It's gotten late. You guys are perfect. All right, well, I'll kick it back. I think I'm going to kick it to Brian. Thanks, everyone.
Thank you, Kathleen. Yeah, and we have 4 more slides, so I'm just going to cover the remaining schedule. We'll do it real quick. So this was tagged for Oregon. The next presentation, or sorry, this was tagged for Washington. The next presentation will be covering much of the same. The carbon impacts will be focused on the CPP plan. Energy efficiency, we'll have a presentation from ETO. There will be some RNG information again, and then distribution system planning, Oregon projects, and then some preliminary results. And then we'll be moving on to Tag 5. Tag 5 Washington will be September 28th. And that's where we'll have final integration results, finalization of plan components, and then action items. Tag 5 Oregon, same items. We'll be doing that in November. And then we'll be filing the draft. Washington is late November. Oregon will be at the beginning of the new year in January. And then we ask for stakeholder comments back. We're giving about 6 weeks for stakeholder comments. It is a large document and it takes time to get through. So we're giving everyone 6 weeks, and then we'll hold an additional tag meeting if needed. February 1 for Washington, and then March 15th for Oregon, if they're needed. And then we'll be filing the IRPs. Washington will be February 24th. Oregon will be April 14th. Sorry about that. So like I mentioned, next steps, we're looking at final integration results, finalization of plan components, proposed new action plan. And just a reminder, if anyone's interested in Tag 4 Oregon, please attend Tuesday, September 20th, and then one of those days is wrong. I don't know which. And then we have September 28th. But I'm going to open it up for questions. I see there's a question. The slides presented today are slightly different from the ones distributed in the meeting invitation. So there were 2 versions. We sent one out last Wednesday, that because we want to make sure we get them out a week in advance. There were updates to it that were sent out yesterday afternoon, and then this morning we made an update to one of the slide presentations. We will be posting this presentation that was presented today out on the website. So that'll be the one that's posted. So yes, this will be the one posted on the Washington website. Are there any other questions? I'll leave it open. But if there are no questions, we can end the meeting. I'm gonna open it up for final comments. If Mark or Bruce, any of the presenters had any final comments they wanted to make. Nothing. I think everyone just wants to go. Oh, you didn't get yesterday's update? It should have been with the meeting invite.
No, I didn't get it, Brian. Did you actually
Okay.
update the meeting invite? I never got an update for the meeting invite, so
Okay,
I think
that's
yeah, I got the original meeting invite had but that's okay. I'll just download it maybe in a couple of days.
yeah. When our IT is able to post it, it ranges. Sometimes they get back when I send in a request to have the IRP websites updated. Sometimes they'll do it the next day, and then sometimes it takes a week or 10 days or so. It kind of just depends on their timeline. IT has other projects they're working on, so
Okay, thank you.
but yeah, we'll try and get that posted as soon as we can. Okay, I'm not seeing any questions. I'll open it up for final questions, and then I'll end it and let everyone go. All right, I don't hear anything. So thanks everyone. Huge thanks to all the presenters today, and thanks for all the external stakeholders and your great questions. So thanks everyone, and we'll be chatting later, and we'll see you at another tag meeting.
Thanks, Brian.
Thank you.
Thank you, Brian.
Thanks, everyone.
Yeah, thanks.
Bye.
Thank you, everyone.